Hello friends, we are starting this subject fundamentals of DBMS, database management system, and this subject will be helpful for the students who are currently pursuing BTech in computer science or electronics and who are currently in first year or second year and they are going to study the subject DBMS. So we will start and we will start from the basic to the deep level. Today is the first lecture, day 1. So let's start. So what is DBMS? What is database actually? That we have to understand. What is database? Database is nothing but the collection of the data. Suppose हमारे पास बहुत सारा data है and we want to store the data somewhere. So what we will do? We will have some platform, we will have some kind of a storage space. So that storage space is nothing but the database. Okay, so where all your data is arranged or organized in such a way so that someone who is the authorized person can easily retrieve the data from there. Correct? So I can say the database is nothing but the well organized collection of the data where the data is stored, where the data is managed so that it can be easily retrieved. Clear? Now, before we proceed with the more concepts of DBMS, there are some basic key concepts that we have to understand. The first concept is data organization. What is data organization? Organization means how your data is organized. For example, suppose I am storing my data. Suppose I am having a class in which there are 10 students, suppose, and I want to store the data of each student one by one in a tabular format, right? You can store your data in a table. You can store your data in a graph format. You can store your data in a document. It can be anything that we'll study in the later classes. Now, suppose I am going to store my data, that the class data in a particular table, right? So how this table will look like? Suppose this is a table where I'm storing my data of students, and the first column will be suppose student ID, second is the name, then the gender, then the age and the grade of the student, then suppose it can be what is the address, communication, what is the email ID, phone number, and so on. Now, what is data organization here? Data organization means how your data is arranged in the tables, right? In a particular row, in a particular column, so that it can be easily accessible to the particular authorized person. Okay. Now the second is data schema. Schema is what is schema? Schema is nothing but like the blueprint of your database. It's like a structure of your database. What is the structure of your database? For example, I am considering the structure is in the table format. So structure is basically schema is basically it basically define what is your table, what kind of table we have, what columns they contain, and how they are related. Okay. Now the third is data manipulation. Data manipulation means it basically suppose I am having a table and I want to insert some new data inside the table, right? I want to update some existing data, or I want to delete some data. So this kind of actions that we are going to perform, these are called data manipulation, right? Data manipulation means the actions that we are going to perform inside the database. Clear? Now next is data integrity. Data integrity means whatever data you are inserting inside your database, right? It should be correct and it should be consistent. For example, as I said, inside this database, suppose this is my table, and inside this database, student ID should be unique, right? 1, 2, 3, 4. This cannot be duplicate. This cannot be same for 2 or 3 students. Name can be same. We can have two name. We can have two students who can have the same name, but a student ID should be unique. So that is the condition. Whatever data you are inserting, it should be correct or it should be consistent. Now, the next is data security. Security means whatever data you are inserting, it should be protected from the unauthorized access. Only the right users who is the authorized person should be able to see or should be able to change the certain data. That is the data security, right? Next is the data querying. Data querying means Query is what? What is the meaning of query? Query means asking some questions, right? Suppose I have stored my data in the table format like this. Now, I want to find out how many students are under the age 15, or I want to find out what is how many students are female in my class. So how I can find out this question? So it should be possible when I will use some kind of a commands, or I will use some kind of a programming. So data querying means to find out the questions, to asking questions to the database, right? Next is data indexing. Indexing means, what is index actually? Suppose I am having a book. Inside the books, in every book you can see that the front page is your index page. What this index page will do? It will help to find out the particular topic to the particular chapter in a faster way, right? Because it will, otherwise it will makes your data very clumsy, right? So in a similar way, inside the database, data indexing basically helping to find out the searching, right? It will basically speed up the process of searching. Clear? Now now the eighth is data normalization. Data normalization means the whatever the data you are inserting inside the database, organizing the data so that it will reduce the duplication, or it will improve the efficiency. Suppose I am inserting the data inside the database. Suppose this is a table, right? And I am having another column, and inside the column, there is the subject they like. So suppose there is a one student, John Smith, who also like math. Then I will insert his row. Then in the second row, he said, ma'am, I also like science subject. So I will also insert the same, his name, and then other details, and in the subject I will insert the science. Then what you will observe, there is a duplication in student ID. This is not be there. This should not be there, right? So whatever data you are inserting, it should not be duplicate. So this is the called the data normalization. So how I will remove this data normalization process? There are some way we can split the data, that we'll understand in the upcoming chapters, in the upcoming days. What is the process of data normalization and how we can improve the data normalization process? I hope this is clear. So in all, whenever a student is studying this DBMS, they are basically should have the clear understanding of what is data organization, what is schema, what is data integrity, what is data querying, what is indexing. All these are very the key concepts of DBMS that we have to understand very well. Now, the next topic is, we know what is database management system. We know the database management system is where we are storing your data, that is a database, right? But now we have to understand what are the advantage of DBMS, why you are studying this DBMS. So the first advantage is data integrity and consistency. What does it mean, data integrity and consistency? That means whatever data you are inserting, it should be correct and it should be consistent. That is the first rule that we have to follow whenever you are inserting your data, so that there is the less chances of error and inconsistencies. As I said in the earlier example of a class, whenever we are inserting the student data, then the student ID should be unique. It cannot be duplicated, it cannot be repeated, right? So DBMS will not allow two students with the same ID, right? So this will avoid the wrong or mismatched data. So this is the first advantage of using the DBMS approach. DBMS will not allow inconsistent data. Now, second is the data security. As I said, DBMS provide the various security mechanisms to protect the data from unauthorized access and misuse. For example, if the teacher entered the wrong marks, right? Or if only the authorized person can access or the change the data. So that is the second advantage of using the DBMS. That is your DBMS system is very much secure. It is very much protected from the unauthorized access. Now, third is the concurrent access and data sharing. What is concurrent access? Concurrent access means there can be a condition when many users want to access the information. Suppose, as I said, in my database, this is a student database. There can be multiple teachers who can access the database. So DBMS allow multiple users to access and update the same data simultaneously. So this is the another feature of DBMS. So data, what we were saying, this data security, then the concurrent access and data sharing. That means multiple users can access and update the data simultaneously. That is the concurrent access. Now next is the data recovery and backup. Data recovery and backup means whatever the data you have stored in your database, it should be, if suppose there is a kind of a system failure, right? That can be happen because system is nothing but a machine, so it can be fail. So your data, that is where you have stored your data, should not be lost. There should be a proper mechanisms for backing up of your data to protect against data loss. So DBMS provide this kind of facility to recover your data and to create the backup. Now next is the data independence. Data independence is whatever data you are inserting, right? And suppose you want to change in the database structure. Suppose I want to change my database structure from table to, suppose, in a graph format. So what will happen? It can be the situation that your data is stored, it is lost. But no, in DBMS, database management system, DBMS allow application to be developed independently of the data storage. That means if you have stored your data and you want to change your database structure, that it will not affect the application, right? Now next is data scalability. Data scalability means DBMS allow to handle large amount of data. Suppose I want to create the database for the large organization, for the company perspective. Then DBMS also allow to handle the large amount of data. Your storage can be scalable to the for the large system, right? It supports the increasing data storage needs of an organization. That is the data scalability from small scale to the large scale. Now next is data integration. Integration means DBMS allow to use or to get the data from different sources into one place, so that, for example, if there is a customer data, right, and the data is coming from the website, right, and also there is a payment data is also coming from the bank, right, there is a delivery data that is coming from the courier service. So all the data is coming from different sources. So data integration basically allow to consider all the data into one database, so that the admin can view the data in a one screen. So this is possible using the DBMS only. Now next is data analysis and reporting. Data analysis and reporting means it provides the tools to retrieve your data, to analyze your data, and to report your data. Means DBMS provides a way so that you can analyze your data in a very easy way. You can create the report for a particular data. Suppose I want to create the monthly sales report for a sales data, then it can be possible with the DBMS. Suppose I want to find out who is the best selling product in a sales product, so that can be possible in the with the DBMS approach. So that is the reason why we use DBMS, because of these 8 advantages. The first advantage was the data integrity and consistency, because it provides the data in a very correct way. Data security, your data is secured if you are using the DBMS system. Concurrent access and data sharing, DBMS allow multiple users to access and update the same data simultaneously. DBMS allow your data to be recovered if the system is failure. DBMS allow the application to be developed independently of the data storage. DBMS also allow to handle large amount of data from the small scale to the large scale. DBMS also handle data from the different sources. That is the data integration. And the last is the data analysis. That means DBMS also help in getting useful reports and useful insights for your particular database. So these are the 8 advantages why we should use DBMS approach. Now, the next topic is what is the history of database application? Why this DBMS application, from where this application was started actually? So that we have to understand. So this DBMS is basically the first DBMS application was started in 1960. In 1960, the IBM developed the first DBMS system, and the system was named as Integrated Data Store, that is IDS. Clear? So IBM developed the first DBMS in 1960, and that system was called Integrated Data Store, IDS. And it was used especially for the mainframe computers, because at that time only the mainframe computers were there. Then after this, there were many other database systems was created, such as IMS, Information Management System, and the Program Data Processor, that is PDP. Now after 1960, 1970, another thing was happened when the relational model was introduced. What is relational model? That we'll discuss in the next PPT. In the next chapter. What is relational model? Relational model is basically the way to create your database, right? And that was introduced in 1970. Then in 2000, the use of data warehousing and the business intelligence was popular. To basically, these were used for the large amount of data. And then in 2020, and the trend of cloud-based database, and which was basically used for large scale database, and then the machine learning was also integrated with the databases to analyze your data, was introduced. And now you can see after 2020, it is very much evolving with the time, because the technology is evolving over the time, and this database and DBMS continue to play a vital role in managing and making sense of the growing amount of data in various fields. I hope this is clear. What is the history of your DBMS? It was first database system was developed in 1960 by the IBM. Then in 1970, the first relational model was developed. Then in 2000, the use of data warehousing and business intelligence BI becomes popular. And then 2020, the trend of cloud-based databases was introduced. Now, the next topic is data model. What is data model? As I said in the last slide, relational data model. But before to understand relational data model, we have to understand the term what is data model actually. So data model is nothing but the way how you are going to, how your data is stored basically. It basically defines how your data is stored, how your data is organized, how your data are related in a database. Or you can say it is basically provide you the set of rules. What are the set of rules to organize your data? So all these things were defined by the data model. Clear? So data models is, as I said, the way we can, how we can store our data. So we can have multiple ways to store our data. So for this reasons, we have several types of data models. The first is the relational data model. What is relational data model? Relational data model, we are having 3, 6, 7 types of data models in our course. First, we'll understand what is relational data model. Relational data model is when we store our data in the table format in relational data model. And we are having rows, and then we having columns, and we will store our data. So that is a relational data model. Clear? Then hierarchical data model. Hierarchical data model is when we store our data in a tree structure. That means there is a parent and a child kind of a relationship. We are having one parent, that is, suppose consider the example of a company database. In a company, we will start from the we will have a tree like structure. Then we have a department, multiple department. Then for each department we are having employees. So that is like a hierarchical. So this model basically organizes the data into a tree like structure. Clear? Third is the network data model. Network data model is when we organize your data in a graph like structure. When a child can have multiple parents. For example, when you record have, it basically supports the many to many relationship. In hierarchical data model, the relationship is one to many, but in network data model, the relationship is many to many. For example, a student and a course system, a student can take many courses, right? And a course has many students. So this is like a many to many relationship. So for this purpose, we use network data model if we have a many to many relationship. The next is object oriented data model. Object oriented data model, when we are supposed to represent your data as an object and as a class, and there is a relationship between them, then we use object oriented data model. For example, suppose I am having a class vehicle, and I am having objects like car, like bike, like rickshaw, and all cycle. Then for each object, we are having some data, like what is the speed of the particular car, what is the color of the particular car. So these are the examples of object oriented data model when we are supposed to represent the data as object and classes. Next is document data model. Document data model is when you organize your data as a collection of documents. For example, we are having XML sheets when we store our data into the form of documents. Then we have a key value data model when we organized your data in a key value pairs. What is example for this? Let's consider I am having a user ID, and according to that user ID, there is a name of person. So there is a value, key value pair, ID and name, ID and name. So when you store your data like this, there's a key value pair, then this model is known as key value data model. And the last is the graph data model, where the data is stored in the form of nodes and edges like a graph, right? So there is basically the relationship, what is the relationship between nodes and the graph. What is the example for this? Consider like a social media. And social media, nodes are your people, right? And edges are like the friends, how the people are basically connected to the particular friend. So this is a graph data model. So in all, just for the clarity, data model is how your data is stored. Now in total, we are having 7 types of data model: relational data model, hierarchical data model, and each data model has several advantages and disadvantages. Based upon your application, whatever you want to do, you will choose which type of data model I have to use for my database, right? Suppose I want to create a database for the company, then it is required to arrange your database as a hierarchical data model. Suppose I want to store my data for a school database, so I will use relational data model. So each data model has all is strength and weakness, and the choice of the data model is depend upon the specific application, whatever you are going to use. But yes, for your the most popular data model is relational data model. Why? Because here the data is stored in the form of tables. So it is easy to maintain, it is easy to understand, it is easy to implement. So that is the reason in most of the cases we use relational data model. Now, the next topic is data instances. What is data instances? Data instances is basically the data that you are going to store. For example, as I said, in a table, the particular row of a particular student is your data instance. Okay, for example, if I am having an employee table and the column is employee data, what is the employee name, what is the employee salary, what is the employee position, then the each row of the employee is known as the data instances. Clear? So data instances can be updated, they can be inserted, they can be deleted from the database depending upon the DBMS capabilities. So thank you so much, class. I hope you liked the video. And in the tomorrow section, we will discuss the other parts of the DBMS. We will also discuss what is ER diagram, what is entity, what is relationship. I hope you like the video. Thank you so much.